All right. I know we did some of these in class, so we'll hit the rest. Now, what I like to do is I like to check your homework, and I put it on the board so you can start checking, and then we'll have a chance to go over it. Make your corrections. Don't leave them incorrect on your paper, because when you go to study from them, that's what you see. So make yourself notes, change them, whatever you need to do. And stop me. I kind of go through it unless you have a question. So stop and say, could you go back, if you go over that one again, if you want me to redo it, I'll redo the whole thing, whatever it takes. So in your number 2, you have a discrete set. We pulled out the x's for the domain, the y's for the range. We talked about, I think we did this one, if it's a function, every x has one and only y value. If it's not, you're going to think your x's repeat. I think we talked about, did we do number 6 in class? What it would take for that not to be a function, that if it hit one of those x values. Again, look for your x's to repeat. I don't care about one-to-ones right now, just basic functions. One-to-ones, we do those every time we do inverses. So with each topic, when we have an inverse, we'll discuss that again. We talked about this domain, the domain of real numbers. We talked about working everything in interval notation. We had this one too. Anybody know what type of graph number 9 is? Absolute value. Absolute value. And what you're going to be able to do is to say up your basic absolute value graph. And it dropped 3, see it's a 1, 1, 1, 1, 2, 2. It's an absolute value basic graph, but it dropped 3 down. You're going to be able to create those equations when we do transformations. Normally we don't get any negatives out of an absolute value except for that transformation caused it to shift. So there's the 3 drop down there. So that's why we have negatives there. When you have a horizontal line, a y equals, you have every x assigned to the same y, and that's okay because x is still only assigned to one y value. And again, it passes your horizontal line, your vertical line test. When it's a vertical line, and that x has all those y's, that's when it's not a function. Okay? This type of set, is this called a discrete or continuous? Discrete. Good. They're just the exact points. They're not connected. So we pull out the x values, we pull out the y values. And we just leave it at that. Is it a function? Yeah. Every x has one and only one y. Okay, number 12. Is number 12 a function? No. Doesn't pass a vertical line test. This is a circle. Box it in. Go from your extreme x's and your extreme y's. And interval notation is so nice when you have one of these. You make your points, and that's it. Much easier than the old inequality statements. Now, 13, this is a piecewise. We talked a little bit about piecewise yesterday. First of all, is this a function? No? Why? What? Verticals, it passes the vertical line test. Yeah. How about through here? Yeah, this guy's open, so we can't count his. So if one's open, one's closed, it's good. And this guy also, one's open, one's closed, it's good. So this is a function, this is a piecewise. And some of you said you weren't familiar with piecewise, but piecewise would say, for instance, in this x value, when it's less than -2, you have one equation. From this x value from here to here, from -2 to 1, you have another equation, and it might be this. That. And then you have a third equation, when x is greater than or equal to 1. There's your overlaps right here. One of them has to be open, one of them has to be closed. And you'll be able to still have a regular function. You just made it in pieces, which is why we call it a piecewise. And we'll work on those. But these are nice graphs for you to get your domains and your ranges down. Now, your domain are any of your x's. So you look, and you covered all of these, you covered in between, you covered all of those. Your domain of real numbers. Your range, this went on and on and on and on and on. So from here down, you were okay. This went from here to here, and then we stopped, which is why I drew this line. So your range is only going to go as high as 3, but not include 3. You use any x, but your range stops at 3. Good? These are great graphs for you to work on domains and ranges. You're going to do some more of those for homework tonight. I love those graphs. Is this a function? Does it pass a vertical line path? Now, your domain is in segments. Your domain comes from -infinity. It stops at -1, and we can use -1. Then it restarts at 1, which we can't use, to infinity. Your range is just two numbers. It's either -2 or it's +2. Now, notice these brackets. This is not the same as this. This is an interval notation. This is just your discrete set. I can only use -2. I can only use 2. That's just the sample space right there. Okay? That's just like saying y is equal to 2. Y is equal to -2. Y is plus or minus 2. Good? We do a lot with graphs here. Number 15 gives us a parabola the other way. This is your x equals the y squared something or other. So it has a little bit of a different effect here. Your domain is going from -infinity to 0, and it's stopping at 0. And you can use 0. Your range of the numbers, as opposed to your traditional y equals x squared. And number 16, I don't know if you remember seeing this. We saw it in Algebra 1, and we probably very quickly look at it in Algebra 2. This is called a sept function. It's sometimes called an integer function. And in your calculator, it's the int one, integer. It only returns an integer, nothing with decimals or fractions. So you can use any x. If you look, this is constantly continuous. It's a function because one's open, one's closed. And then it jumps to the next step. Jumps. You see the series of steps it makes? It makes a series of steps. This keeps on going. But what happens is you have no in the middle of your y's, no fractions, no decimals. It'll just return the integer. Okay? So your domain is all real numbers. Your range is the complete set of integers. This keeps on going endlessly. If you wanted to, you could tell me that it used, if you only saw it from here to here, you could say that your integers went from -5 to +3, only integers, if that's what you saw it just as that. But it's something that goes continuously. So your range only returns your integers. But your domain uses anything. We don't do that much with the step function, but we like to know a little bit about it. This guy, this is still a function. And we have cases where we have pieces of your diagram and then one little point. So it still passes a vertical line test. The domain is segmented because it goes from negative infinity, stops at the -1, then and you can't use -1. Then it resumes at the 2, and that little dot on the bottom is a 2. That does fill it in. So that's why the 2 has a hard bracket, not a soft bracket. And your range says you can use the 0 or from 2 or greater, but not including 2. I don't know where this came from. This is a piece of something else somewhere. I think when I moved it up, it brought another segment up. And the last one is a nice little section of one. Just box it out. Box it out so that you can see where your x's go from. And interval notation is so nice for this. From the -3 to the +3. And look to see, this guy's open, this guy's open. So there's your soft brackets. Do the same with your y, from 2 to 4. And this guy's closed, this guy's closed. There's your brackets. Okay. How'd that work for you guys? Good? Just, some nice little review in domains and ranges, and so that everybody is on the same page. All right, today we're going to talk about your 3 restrictions. Your 3 restrictions in all of our functions. Because we work in the real number world, we have 3 basic restrictions. This is probably going to be one of the most important lessons that you get, because these restrictions we use all the way through precalc. We're major restriction people in precalc. And what's nice is, tomorrow we're going to start graphing these things as well. You get to see it on your graph at the same time, which is nice. Now, your first restriction is your fraction. And what can you not have in your denominator? 0. So our rule is set the denominator equal to 0. And see which x values, or whatever your variable is, that you cannot use. So basically we say, okay, x cannot be 0. This is restricted. This is one of your restrictions. So to see what available domain we can use, we look at your number line, and we take out the 0. And we say you can use everything else that you want, but you can't use 0. So your restricted domain says -infinity to 0, can't use 0, jump over that 0 to infinity. So we have a restriction. It's not allowing me to use the 0. I can use everything else but that. Now, no matter how bad that looks in the denominator, we still follow the same rules. Are you okay? You need water? Okay. We take this, and we set this equal to 0. Same rule. Take whatever's in your denominator, set it equal to 0. And you can factor in this case, or you can add 4 to both sides and take the square root. So if you add 4 to both sides, and you took the square root, you have to remember whenever you undo a square, you get a positive and negative. So these are the restrictions. I'm not allowed to use a 2 or a -2. I can use anything else but a 2 or a -2. So I take them out of my allowable domain. And what's left is my restricted domain. From negative infinity to negative 2, then I jump over that negative 2, and I can use from negative 2 to 2. Then I jump over that 2, and from 2 to infinity. This is my restricted domain. See the difference between a restriction and then what's left for you to use, the rest of your domain? Okay. These are so important. These are 3 little restrictions that will follow you this entire course. The entire course. Good so far? Okay. Second restriction is your radical. In the real number world, what can we not have under a radical? Negative. Can we do radical 0? Can we take the square root of 0? Square root of 0 is 0. So in looking at my number line, I say I can use the 0, I can't use any of these guys, and I can use this. Anything greater. I just can't be negative. No negatives allowed. So my rule is to take whatever's under the radical and I set it greater than or equal to 0. Because I need that result to be greater than or equal to 0. I take this and I say x is greater than or equal to 0. So my restricted domain says 0 to infinity, right? All I can't put under there is a negative number. I can use 0 and anything positive. I use that rule no matter what that looks like. No matter what's under my radical, I use the same rule. So for this guy, I just take this, same rule, greater than or equal to 0. This whole thing that's underneath there cannot be negative. It can be a 0 or a positive number. So I just follow the rule. I subtract 3. So from negative 3 to infinity is my restricted domain. I can put a negative 3 in there. That gives me a 0. Negative 2 gives me a 1. Negative 1 gives me a 2. I can use all those negative numbers just because of that plus 3. When we get to your transformations, you're going to see that your radical, like this, when it's close to the x, it goes in the opposite direction. It's going to graph this way so that you can kind of see your domain there when we do your transformations, because we do a lot of graphing off your transformations. So one basic rule, whatever's underneath that radical sign, greater than or equal to 0. And last, we combine it. We put a radical in your denominator. So it can't be negative, and because it's in the denominator, it can't be what? 0. So our rule is under the radical now is just greater than 0 because it can't be 0. So we take this guy now and we say x is greater than 0. So our domain says you can use any number, but you also this time can't use 0. See the difference from here to here? This one we were allowed to use 0 because we have a radical 0. This one we can't because radical 0 gives me a 0 in my denominator. 3 basic rules, that's it. And 2 unique ones, one is combining them. So just like we did this here, when it was just a plain radical, we set it greater than or equal to 0. When it's underneath it in the denominator, we just say greater than 0. So all that changed from here to here was the fact now that you can't use negative 3, because negative 3 will cause you to be 0. restrictions. That's it. Questions? No? Okay. I'm going to give you guys some to find. Find me your restricted domain. What was that? Okay. All right. Thank you. I'm putting it out there today. I'll put it out there today. I'm going to show you tomorrow how to access it. Okay. Find your restricted domain. Okay. Take a minute and work on it. What do I do at number 1? Factor it. So my rule is take the denominator, set it equal to 0. And I have a quadratic, so I factor. And what are my factors? What is that? 3 and 2. And they're both positive. Then I set my factors to 0. So x cannot be negative 3, and x cannot be negative 2. These are restrictions. So I therefore take them out of my domain. Take them out. So you are allowed to use everything to the left, everything in the middle, everything to the right. So your domain would say negative infinity to negative 3, jump over negative 3, negative 3 to negative 2, jump over negative 2, negative 2 to infinity. Okay? You can factor, set your factors equal to 0, because anything in the denominator cannot be 0. So when you do this, if it's negative 3, it causes that product to become 0. If it's negative 2, it causes that product to become 0. So there's two values that are not going to work here. Okay. Number 2, what should I do for number 2? Set this underneath the radical to what? Good. Greater than or equal to 0, because I'm allowed to have a 0. So I subtract 2, and I get, but I have a negative x. So what do I have to do? Divide by negative 1. And what's the rule when you divide by a negative? Good. Change the sign. So there's my domain. Negative infinity, stop at 2. And I'm going to put this on my number line for a minute. And I'm going to see, does 0 work in here? Yep, 0 plus 2. Does 2 work in here? Negative 2 plus 2 is 0. Does 1 work in here? Yep, negative 1 plus 2 is 1. How about a negative number, like negative, maybe negative 5? Negative 5, a negative of a negative becomes positive. So I'm good to go. So my restricted domain in this case says negative infinity, stop at 2. And the last one, it's under a radical in the denominator. I set this to what? Greater than 0. And I solve. I add 3. I divide by 2. And you're allowed fractions. So x is greater than 3 halves. No equal to. If I put a 3 halves in here, 3 halves times 2, the 2's cancel out, and I get 3. 3 minus 3 is 0. I can take the square root of 0, but I can't have a 0 in the denominator. So that's why there's no equal sign here. So my domain says 3 halves to infinity. good.